Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is June 2018, Paper 2, Foundation Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Question 1. Circle the expression that can be written as 2y. Well, 2y is just y plus y. Question 2. Circle this decimal that is greater than 3/10 and less than 2/5. Okay, now you can write 3/10 as a decimal as 0.3, can't you? You've got units and tenths, so 3/10 is just 0.3. 2/5 is the same thing as 4/10, and so that must be the same thing as 0.4. So we're interested in decimals that lie somewhere between these two. That one's too small. That one's too small. That one's on the cusp, isn't it? It's actually the same as that one, so it's not less than 0.4. So it must be that one there, 0.32. Okay, question 3. What is 625 as a power of 5? Circle your answer. Well, if you don't know this one already, well, you should know that 5 squared is 25, and you should know that 5 cubed is 125. So I'm suspecting that 5 to the power of 4 might be 625, but it is the calculator paper. So why not just pull up a calculator and tap that in? 5 to the power of 4 equals, you can see that is 625. Okay, so it's 5 to the 4. Question 4. Circle the order of rotational symmetry for this shape. Now, rotational symmetry is what you get, well, it's the number of times a shape lies on top of itself if you spin it around 360 degrees. Okay, so if you're not quite sure about this, you can always get some tracing paper from the invigilators, trace the shape, and then stick your compass or pencil tip in the middle of it, and then turn it slowly around and count the number of times it looks the same. If you do that, you should find that it fits over itself 8 times exactly. So the order of rotational symmetry of the shape is 8. Question 5. Work out the value of 3 to the power of 6 minus 841. Question 5. Work out the value of 3 to the power of 6 minus the square root of 841. Okay, now this is just simply a job for your calculator. So let's just pull that up and type it in. So 3 to the power of 6 minus the square root of 841. My calculator tells me that's 700. Which is a lot of marks for just tapping something into the calculator. Good job. Question 6. Gemma has 4 groups of friends on a social media site. The table below shows the number of friends in each group. So in her family group, she's got 8 friends. In her netball group, she's got 8 friends. In her school group, she's got 26. And in her guides group, she has 11. Now, it asks, which group is the mode? Now, mode means the most or most frequently occurring. So we can see that this one was the biggest number. So this one is the mode. So the mode is not the biggest number, it's the group that has the biggest number. So the mode is school, not 26. Okay. Gemma wants a pictogram to show the information. She has drawn the first 2 rows and we need to complete the pictogram. Okay, so you can see for family and netball she's drawn 2 circles, and we know from the data up here that family and netball were both 8, so that means 2 circles must be 8 friends, so 1 circle must represent 4 friends. Okay, so it's important to complete the key. That will be the first mark of this question. The next 2 marks we'll get for drawing the right number of circles for school and guides. So if each circle is 4 friends and we want to draw enough circles to represent 26 people, 26 is, well, how many 4s is that? 5 4s are 20, 6 4s are 24, 7 4s are 28. So it's 6.5, isn't it? 26 divided by 4 is 6.5. So we're going to have to draw 6.5 circles here. 1, 2, 3, 4, 5, 6.5 circle. Now notice I tried to make them all the same size and line them up with the other circles above it. They should kind of fall into neat columns. And then we've got to draw 11. So she had 11 friends who were guides. So if I draw a circle for 4, 8, then if I draw another whole circle, that would be 12, which is 1 too many. So I need to represent 3 friends with a circle that represents 4 friends. So I'm going to draw 3/4 of that circle, which is actually not the easiest thing to draw. Looks like something like that. Kind of a decent attempt to draw 3/4 of a circle will get you the marks. Question 7. E is 3 more than D and F is 5 less than D. Write an expression for E in terms of D. Well, we know that E is 3 more than D. So E is equal to D plus 3. E is 3 more than D. Okay, E equals D plus 3. In part B, we're asked to write an expression for F in terms of D. Well, we know that F is 5 less than D. So F is going to be D subtract 5. And then the last part says, work out E minus F. Okay, we want to know what E minus F is. Now we've just worked out an expression for E. It's up here, look. D plus 3. So our E here, I can replace down here as D plus 3. That's my E value. And I'm going to subtract F. And I know up here that F is D minus 5. So I'm going to subtract D minus 5. Now if I just write it down like that though, it's wrong. I need to put it in brackets because I'm subtracting D minus 5. Okay, so I've got D plus 3 subtract D minus 5. Okay, so D plus 3. So D minus 5 was my F, wasn't it? Okay, so I've got D minus 3. Now removing the brackets, that's going to be minus D, and minus 5 is plus 5. That's why I had to be careful about just writing it down without the brackets. So D plus 3 minus D plus 5. So you can see I've got D minus D. So those two things cancel each other out. And I'm left with 3 plus 5. And 3 plus 5 is 8. So my answer is 8. E minus F is 8. Question 8. The numbers 1 to 12 are put in a grid. 2, 4, 5, 7, 10 and 12 are shown, so they've put some of the numbers in, and I suppose we have to work out where the others go. So it says each of the 4 sides of the grid must add up to 26. Complete the grid using the numbers 1, 3, 6, 8, 9 and 11. Okay, let's write our numbers 1, 3, 6, 8, 9 and 11 up here. These are the ones I need to fit into the diagram. Now I know, I've been told that each row has to add up to 26. So these 4 numbers here need to add up to 26. And these 4 numbers here need to add up to 26. And each column needs to add up to 26. So this column needs to add up to 26. And this column needs to add up to 26. Okay. So probably the best place to start is the place where I need to put the fewest numbers. So if you have a look at this first column here, this column here needs to add up to 26. Okay, and I've already got 3 numbers in there already, so I need to find 1 number to complete it. So 7 plus 4 plus 12 is, what's that, 12, 16, 23. So I need to put a number in there that makes it 26, so it must be the 3. Okay, so I'm pretty confident that the 3 belongs there. Okay, so I've used up my 3. Right, so where next? Okay, now putting that 3 there means that out of this row, I've now only got 1 number missing. 3 plus 5 plus 10 adds up to 18. So the missing number then needs what I need to add on to 18 to make 26, which has got to be the 8. So the 8's going to have to go in there. Okay, right, now the next 2 rows are a little bit more tricky. I've got this bottom row here, but I now have got 2 missing numbers, which adds up to 26, plus I've got this column here, which has currently got 3 missing numbers, which adds up to 26, and one of those missing numbers is shared by the numbers that I'm going to put into the row. So let's have a look at the row first, because I've only got 2 missing numbers there. So at the moment, this row has got a 7 in it and a 2 in it, which adds up to 9. Now altogether, it needs to add up to 26. Now 26 subtract 9 is what? Is 17. Okay, so we need to find 2 numbers that from this list of numbers that we've got left that add up to 17. Now looking at the numbers we've got, the only way I can see of making 17 is picking the 11 and the 6. So these 2 numbers here. But at the moment, I don't know if it is 6 and 11, or it might be 11 and 6. I'm not quite sure which way around it goes yet. But probably I can work it out from the other column. If I have a look at the column, I've got a 10 in there already. I've got an 11 or a 6 at the bottom, and I've got 2 other spaces. But on the left-hand side, our numbers left, we can see we've only got 2 left. We've only got the 1 and the 9 left. So those 1 and the 9 have to go into that column. So I'm pretty sure that that's 1 and that's 9. Doesn't really matter which way around they go. So then if I've got 1 and the 9 there, then it must be the 6 that goes in that column, which leaves the 11 there. So now all the columns and all the rows add up to 26. Question 9. In this question, use 1 foot is 12 inches and 1 inch is 2.5 centimeters. And we need to change 5 feet 8 inches to centimeters. Okay, so I've got 5 foot 8 inches. Did you know that you could do feet and inches with those symbols? It's a bit old school, but yeah, that's what you can do. 5 foot 8 inches. And I want to convert that into centimeters. Okay, so let's find out how many inches I've got altogether. So obviously I've got 8 inches here, but how many inches are in 5 feet? 5 feet is equal to 5 times 12 inches then, isn't it? 5 12s are 60, so that is equal to 60 inches. So 5 foot 8 inches is the same thing as 60 inches plus 8 inches, which is 68 inches. Okay, so now I know that 5 foot 8 inches is 68 inches. I can then convert my inches to centimeters. 68 inches is, well, we know up here that 1 inch is 2.5 centimeters. So taking our 68 and multiplying it by 2.5, we shall know the number of centimeters. So put up the calculator. 68 inches times 2.5 is giving me 170 centimeters, which is my final answer, 170. Question 10. Which of these numbers has exactly 4 factors? Circle your answer. Okay, so I suppose what we need to do is work out all the factors and count them then, don't we? Now I tend to do factors in pairs, so that way it's easier not to miss any. So if I take the number 4, 1 and 4 are my starting ones, then I've got 2, well 2 times 2 is 4, so I've got a total of 3 factors there, haven't I? Okay, let's have a look at 8. 8 is 1 and 8, and 2 and 4 is 3. No, 3 doesn't go into 8, so it's got a total of 4 factors. 12, that's 1 and 12, 2 and 6, 3 and 4. Now notice in this technique I'm starting at both ends, 1 and 12, and I'm kind of working down towards the middle, and then eventually I'm going to meet myself in the middle, and I know I've not missed any out that way. So I recommend you do search for factors this way, in factor pairs. So 1 and 16 go together, 2 and 8, 3, nope, 4, yes, 4 times 4 is 16, so 4 is a kind of a single one by itself. So 12 had 6 factors and 16 have 5 factors. Now we wanted the one with exactly 4, so it's going to have to be the 8. Okay, so factors normally come in factor pairs unless it is a square number, in which case you'll have an odd number of factors like we've got here and here. So it's actually a good way of testing whether or not a number is a square number. It's just count the number of factors. Question 11. Nick has a 6-digit code. He remembers it as 3 2-digit numbers. Now the first number is between 10 and 20. The second number is 3 times the first number, and the third number is 5 times the first number. All 6 digits are different. Work out the code. Oh, this is a bit of a crazy fun question. And I think it's going to take a little bit of trial and error in order to work it out. Okay, I'm going to be systematic about it. Now, the first number is between 10 and 20. So I'm going to write down my possible first numbers and then work out what my second numbers would be, and then work out what my third number would be, depending on what I pick for the first number, until I get one that I can match all 3. So the first number between 10 and 20 is 11. Okay, now immediately I'm going to rule 11 out because all 6 digits are different. So it isn't 11, is it? Because 1 matches with 1. So it isn't 11. Let's go on to 12. 12. So if the first number is 12, then the second number is 3 times the first number. 3 12s are 36, and the third number is 5 times the first number. So the third number is 5 times the first number. 5 12s are 60. Okay, so here we've got a 6 and a 6, so that isn't working as well. They're not all different digits. Okay, so let's try the next one. 13. So if the first number was 13, then the second number would be 3 times as much. 3 times 13 is 39. Again, no good. 3 and 3, so that isn't going to work. Let's try 14. 14. 3 14s are 3 10s are 30, 3 4s are 12, so that's 42. So no, another bust. 4 and 4. Can't have that. Let's try 5. 15, sorry. 15. 15 times 3 is 45. Oh no, not doing very well here. Another bust. 16. Should have started at the other end. 16. 16 times 3 is 48. Oh, we managed to get past the first one this time. And then 5 times 16. 5 16s are 80. No, again, that isn't working. I've got an 8 and an 8. 17. 17 times 3 is 30, 51. Okay, and again, that one's no good because I've got a 1 and a 1. Let's try 18. 18 times 3 is 30, 54. Okay, so I made it past the first one. And then the next one then will be 18 times 5, which is 90. Right. Okay, I think finally we've cracked it then, haven't we? We've got 6 different digits, which are all different. Okay, so the code is going to be 1, 8, 5, 4, 9, 0. Question 12. How many minutes are there in 5 1/4 hours? Okay, well, there are 60 minutes in an hour. So 5 hours is going to be 5 times 60 minutes. 5 60s are 300. And a quarter of an hour. What's a quarter of 60? A quarter of an hour is 15 minutes, isn't it? Okay, so altogether we've got 315 minutes. It's that one there. Alternatively, you could have just typed the whole thing in on your calculator. So using the mixed number key, which is shift, and then the fraction key, then I can put my 5 in there, my 1 in there, and my 4 in there. 5 1/4 times 60 minutes is 315. Okay. Let the calculator take the strain. Question 13. Here is a formula for the amount of water needed to cook rice. We're told that W is equal to 1.5 R plus 0.5, where W is the number of cups of water needed and R is the number of cups of rice to be cooked. Right, so it says how many cups of water are needed to cook 7 cups of rice? Well, if we're using 7 cups of rice, then R is equal to 7. Okay, because it was R that was the number of cups, wasn't it? R is the number of cups. Now, we're going to sub that carefully into the formula. So our formula is W equals 1.5 R plus 0.5. So replacing R with 7 and then working it out then. So what is 1.5 times 7 plus 0.5? So on my calculator, 1.5 times 7 plus 0.5, that comes out to be 11. Okay, so my answer is 11. Part B says, how many cups of rice can be cooked with 20 cups of water? Okay, so remember our formula was W is equal to 1.5 R plus 0.5. Now this time, I know the W and I want the R. So you can either sub it in and rearrange, or rearrange and then sub in. I think I'm going to rearrange first. So I've got W equals 1.5 R plus 0.5. So subtracting 0.5 from both sides. So minus 0.5 minus 0.5. They're going to cancel. And I'm going to be left with W minus 0.5 is equal to 1.5 R. Okay, and then dividing both sides by 1.5. It's going to leave me with R on the right, and that is equal to W minus 0.5 over 1.5. Okay, so I'm going to switch that around to put R at the front, and then I'm going to sub in for W. So we're told that W is 20. Let's just write a 2 properly there. 20 minus 0.5 divided by 1.5. Okay, going to tap that into the calculator now then. So calculator, what is 20 minus 0.5 all divided by 1.5? That's 13. Just take care with the division there when you're typing it into your calculator. You can either wrap it in brackets or you can subtotal and then divide. Either way, just don't just type it in straight, otherwise it will do the division before it does a subtraction, which is not what you want. Question 14a. Use your calculator to work out 9.95 squared times 29.8. Okay. So we've managed to gain quite a few marks already in this paper just by being able to type nicely into my calculator. So 9.95 squared times 29.8 equals, write down your full calculator display. So 2950.2745. Okay, that's what I got. Right, question 14b. Is your answer to part A sensible? Use approximations to decide. You must show your working. Okay. So what asking me to approximate that answer now and compare it with my answer to make sure that I did it correctly. Okay, so let's do that then. So if I look at 9.95, I'm going to round each one of these numbers off to one significant figure. So the first significant figure in 9.95 is the 9, which is in the units column. So 9.95 to the nearest unit rounds up to 10. So I'm going to get 10 squared times 29.8. So the first significant figure of this number is the 2, which is in the tens column. So let's round 29.8 off to the nearest 10, which is 29.8 is nearest to 30, isn't it? It's nearer 30 than 20. So it's going to be 10 squared times 30. Okay, so let's work out down here 10 squared times 30. Well, that's just 100 times, not 106, 100 times 30, which is 30 with 2 extra zeros, 3,000. Okay, so my estimate was 3,000. My actual answer was 2,950. So that's not bad, is it? It's only 50 out, which is not too much when you're talking about thousands. So yeah, I'm going to say it was sensible. The graph of y equals 4 minus x for values of x between -2 and 5 is shown on the grid. Yes, it is. 5a. On the grid, draw the graph of y equals 2x minus 5 for values of x from -2 to 4, up to 5. Okay, so we need to draw another graph on here. Now, in order to draw a graph, the easiest way to do it is to plot a table of values first. So work out our coordinates, really. So we need to go from -2 up to 5. I'm going to pick some points along the way then. So I'm going to go for -2, 0, 2, 4. Let's just do 5 for good luck. Okay, I'm going up in 2s and I'll chuck the other end point in. And I'm going to put each of these values in the equation y is equal to 2x minus 5 and work out what the value of y is. Okay, so let's take the first one, x equals -2. So what is y when x is -2? Well, if it's -2, it's 2 lots of -2, which is -4. Subtract 5, which is -9. Yeah. When x is 0, I'm going to have 2 lots of 0 minus 5. 2 lots of 0 is 0, minus 5 is -5. When x is 2, I'm going to get 2 lots of 2 minus 5. 2 lots of 2 is 4. Subtract 5 is -1. what about when x is 4? 2 lots of 4 is 8 minus 5 is 3. So that's 3. And then finally, when x is 5, 2 lots of 5 minus 5, 2 lots of 5 is 10. Subtract 5 is 5. Okay, so I've got enough points here to plot. Plenty of points. So I've got the first point at minus 2, minus 9. Minus 2, minus 9. Well, this scale has got minus 8 and minus 10 marked. It's going to be halfway between, isn't it? So minus 2, minus 9 is that point. Right, next one, 0, minus 5. 0 minus 5 is here. My next point is at 2 minus 1. 2 minus 1 is going to be there. And then I've got 4, 3. 4, 3. I should have gone for the odd numbers. And then I've got 5, 5. 5, 5. Okay, so now you should notice that all my points lie in a straight line. Well, this is a linear graph. That's what I was expecting to happen. So they should all be lying in a straight line, which means I should be able to draw a straight line through them all with a ruler, which is what I am expected to do. Let's just find a thinner line. So I'm going to draw a line through each of these points. Okay. Now your point should stretch the full length of the graph paper. Don't start and end with the first point. There are more points that you can draw, so you'll see that I've started beyond my first 2 points that I drew. Okay. Well, they intersect somewhere. I wonder if I'm going to be asked about that. Oh yes. Use your graph to solve 2x minus 5 is equal to 4 minus x. Now you'll remember that 4 minus x was the first graph, y equals 4 minus x, that was drawn, and 2x minus 5 was the graph that we drew, y equals 2x minus 5. So we want the points that are on both lines, and the points that are on both lines are that, well, so there's only one of them, it's that point there where the two graphs intersect. Now that is the coordinate 3, 1. So that means the point 3, 1 is on the line 2x minus 5, and it's also on the line 4 minus x. Okay, so our solution is, well, they want the x value. So they don't want the coordinate, they want the x value. And the x value was 3. Okay, so 3. X, oh, steady on. X is 3. Question 16a. BCD is a straight line. Triangle ABC is equilateral. CE equals DE. Okay, so some of that information is on the diagram. I can see BCD being a straight line. I can see CE being equal to DE. That's been given by these 2 marks here and here. So that's clear on the diagram. That's clear on the diagram, but we haven't marked on the fact that triangle ABC is equilateral. So what does that mean? That means that each side of this triangle are the same. So I'm going to mark those the same. And what's more, all their angles are going to be 60 degrees. So I'm going to write that on as well. Okay. So always get into the habit of checking the text up here in front of the question. Many students don't look at that. They just, when they see a diagram, they focus on the diagram and what's beneath it, and they don't check this text up here. And there's often extra info in there that you can add to your diagram that makes all the difference. Okay, so I want to work out the size of angle X. So you can see my angle X is lying on a straight line, because BCD is a straight line, where part of the angle is 60, part of the angle is X, and part of the angle is that one there that we're going to have to find then, aren't we? Okay, so I'm going to use the fact that this triangle is isosceles to know that these 2 angles here are going to be equal to each other. Okay, so each one of these angles here is going to be, well, 180 degrees minus the angle at the tip, 28, and then divide by 2, isn't it? Okay, because we're going to have to share it between those 2 angles. So 180 subtract 28. So what's that? 180 subtract 28. That gives me 152, and 152 divided by 2 is 76. Okay, so that angle there is 76. So that makes that one 76 degrees as well, because the base angles of isosceles triangles are equal. So now I've got 3 angles on a straight line. So then x, what did I write? 18. So my 3 things on the line, 60 plus x plus 76, is going to be equal to a straight line, which is 180 degrees. Okay, so 60 plus 76, just combining those two numbers together, is 136. So x plus 136 is 180. And then look, subtracting 136 from both sides will tell me what x is. So x then is going to be 180 minus 136, which is 44 degrees. Okay, so x is 44. 44. Question 16b. Amber is working out the size of an interior angle of a regular octagon. So basically, she is finding this angle here, isn't she? Or one of the other ones like it. Her method is interior angle equals 360 divided by 8. Oh dear, oh dear, oh dear. Is her method correct? Well, I can tell you straight away that it is not. Okay, the reason for your answer. 360 divided by 8 is a useful formula, but it's not for finding the interior. It's for finding the exterior angle. So exterior angles are 360 divided by n, where n is the number of sides. If I divide 360 by 8, I'm going to get, what do I get? 360 divided by 8 gives me 45. Okay, so what is an exterior angle? Well, if I took my ruler and lay it on my line for on that side, look, and I extend it out a little bit beyond the shape, then the exterior angle is the angle that line makes with the side here. So that one is 45 degrees. Okay, that is the exterior angle. So the interior angle then is going to be 180 degrees, subtract the exterior angle. So my interior angle is going to be 180, subtract my exterior angle. So that's 180 minus 45, which is 135 degrees. Okay, question 17. Here is a map of an island with cities A, B, and C. The straight lines represent roads. And we've got a scale on the side. We've got 1 centimeter represents 200 kilometers. A is due west of B. Write down the bearing of A from B. So A is due west of B. Write down the bearing of A from B. So we're starting from B. If we draw a north line at B, because that's where we're setting off from. So let's just draw a north line on B. So north line is just a line going straight up in the same direction as the other north line I've been given. Then the bearing is always given clockwise from that north line. So if I want to walk from B to A, I'm going to be heading in this direction. Okay, which is 3/4 of a turn, isn't it? So 3/4 of 360, or 90, 90, 90, it's going to be 270 degrees. So the bearing of A from B is 270 degrees. Just take careful of this language of from, just to make sure you know where your starting point is and the direction you're going. Okay, what does B say? B says Umar drives from A to B on the route shown. Kaz drives from B to C on the route shown. Use the map to work out how much further Umar drives than Kaz. Umar drives from A to B on the route. Kaz drives from B to C on the route. So So UMA is going from A to B. That's UMA. And then CAS is going from B up to C, then from here along here and then up to here, up to C. So that's CAS's route. And these two other dimensions are 2.7 centimeters and 2 centimeters, which together 2.7 plus 2 gives you 4.7 centimeters for Kez's journey. Okay, so you got 6.5 centimeters and 4.7 centimeters. Now don't forget that 1 centimeter represents 200 kilometers. So taking my 6.5 times it by 200, that will tell me how many kilometers that have been traveled. 6.5 times 200 is 1300 kilometers, and then 4.7 times 200, what's that? That is 4.7 times 200. That's 940 kilometers. I've forgotten what the question is now. What did the question say? The question said, use the map to work out how much further UMA drives than CAS. Well, then that is going to be a subtraction, isn't it? I'm going to then subtract UMA's journey, which is 1300, subtract CAS's journey, which was, what was it again? 940. So 1300 subtract 940, 1300 subtract 940, so they did an extra 360 kilometers then. 360. Question 18. A shop sells raincoats and umbrellas, and the scatter graph shows the monthly sales from 12 months. So you can see throughout the year that the sales are generally going up. So you can see from the graph you've got vaguely strong positive correlation between the sale of raincoats and the sale of umbrellas, which is not that surprising because I'm assuming that raincoats and umbrellas are bought most when it rains a lot, and you tend to buy them together. So write down the type of correlation shown by the graph. This is what we call strong positive, because it's a clear upward line of best fit going through those. The manager expects sales of umbrellas next month to be £60. Draw a line of best fit to estimate the sales of raincoats next month. So I'm going to draw on our line of best fit. Probably should have done that to answer the first question. Right, I'm going to draw my line of best fit about there, I think. Maybe a bit more higher. It's a little bit subjective. You'll get a fair bit of leeway about where your line should go. You should have roughly the same amount of points on either side. I think I've got like 5 on each side, and it kind of vaguely follows the line of travel up the graph. I'm reasonably happy with that. You will get a fair bit of leeway when you draw your line in. So that's my line of best fit. Then I'm going to estimate the sales of raincoats next month when the sale of umbrellas is going to be 60. So I'm going to look up from 60 umbrellas, or £60 worth of umbrellas. Read up to my graph. And then change direction. And read across to my raincoat line. It's about there, isn't it? Okay, so you can see my line ends up about there, just over 125. Now each one of these little boxes, there are 5 little boxes, and they span a different distance of 25, so each one must be 5. I've kind of drawn mine between 2 boxes, so I'm going to estimate that to be about 127, something like that. Okay, so draw a line of best fit to estimate the sales of raincoats. I think it's going to be 127. Now, like I say, there's a fair bit of give in this question, so don't worry if yours isn't exactly the same as mine. Question 19. Multiply out x times x minus 4. So I'm multiplying out a single bracket. So everything inside the bracket is multiplied by the thing on the outside of the bracket. So I'm going to have to multiply x with x, which is going to give me x squared, and I'm going to multiply x with minus 4, which is going to give me minus 4x. So my answer is that one. Okay, question 20. The ratio of A to B is equal to 5 to 2. How many times larger is A than B? So the ratio of A to B is 5. Can you imagine 5 blocks put on top of each other? So 5 blocks to 2 blocks then. Okay. So how many times bigger is A than B? Well, I could take that block of 2 and I can have another block of 2, so that's twice as big, plus another half a block of as well. So it's actually 2.5. Fits in 2.5 times. Okay. 21a, a circle has a radius of 4.2 centimeters. Work out the length of the circumference. Give your answer to 1 decimal place. Okay, do you remember the formulas for circumference and area? Cherry pie delicious, apple pies are 2. Okay, so that's a nice way of remembering it. So we want the circumference, don't we? Which is this one. So circumference is pi times diameter. A diameter is 2 lots of the radius. So if the radius is 4.2, then the diameter is going to be twice that. It's going to be 8.4. So then I can use c equals pi d, which is 8.4 times pi, which on my calculator I can type in as 8.4 lots of pi, which is 26.4 to 3 significant to 1 decimal place. So I'm going to have to round it off to 1 dp, which is 26.4. Okay. Right, part B says the circle below has center O. Draw a sector on a circle. Now a sector is a bit like a pizza slice or a pie slice. So what you want to do is to draw 2 lines, 2 radii reaching out from the center of the circle. So there's one, and I just need to do another one in another direction. Okay, so a sector is made up of 2 radii, they're called a radius and a radius is 2 radii. So 2 radii and the arc between them is a sector. So that there is a sector. 2 ordinary fair dice are rolled. So fair means that they're going to have their theoretical probability values. Complete the tree diagram. First dice, second dice, 1/3 less than 3, and what is more then? So 1/3 and 2/3 then, isn't it? So each kind of branch of your probability tree should add up to 1. So I've got 1/3 in one direction, I must have 2/3 in the other. Okay, and again over here 1/3 and 2/3, 1/3 and 2/3. That was easy. Okay, so then work out the probability that both dice land on a number less than 3. So both dice land on a number less than 3 is this route, less than 3 here and then less than 3 here. Okay, so I've got to go up that branch. That's the only way I can go, isn't it? That both land on a number less than 3. So the probability that both less than 3 is going to be those numbers along the route multiplied together. So that one multiplied by that one, isn't it? So 1/3 times 1/3, which is 1/9. That's a super easy probability question. Match each sequence to its description. One has been done for you. You can see here we've got 1, 2, 3, 4, 5, 6 different sequences, and the first one is mapped as a Fibonacci sequence. It is, look, so 1 + 1 is 2, 1 + 2 is 3, and with a Fibonacci sequence you get the next number in the sequence by adding together the last two. You can see that's the case all the way through there. What about the next sequence? I've got 1, 2, 4, 8, 16, 32. Now, from one term to the next, you can probably see that I'm multiplying through by 2. It's doubling each time, isn't it? It's times 2. So times 2 times 2 times 2. So anything that has a common ratio like that, multiplied through by the same number, that is a geometric progression. Next one, 1, 2, 3, 4, 5, 6. That one is going up in even jumps. It's +1 each time, +1, +1, +1. So any sequence that's going up in a fixed number each time, that's an arithmetic progression. Okay, what have we got now? 1, 3, 6, 10, 15, and 21. Now, if you drew those as a sequence of dots, I think you can probably see that this is the triangle numbers. It's that one there. 1, 4, 9, 16, 25, 36. I hope you can recognize is the square numbers, and that leaves me with the cube numbers 1, 8, 27, 64, 125, 216. Yep, that all looks good. Okay, all done. So the table shows information about the population of a city. And we can see the population in 2001 was 420,000, and the population in 2011, it's gone up. It's now 480,000. Okay, Liam claims from 2011 to 2021, the population of the city will increase by the same percentage as from 2001 to 2011. He works out the population increase from 2001 to 2011 is 480 subtract 420, which is 60,000. So the population in 2021 should be 480 plus 60, which is 540. Does the population of 540 match his claim? You must show your working. Okay, so he has said here that from 2011 to 2021, the population of the city will increase by the same percentage as from 2001 to 2011, but he hasn't actually worked out what that percentage is. All he's done is subtracted one number from the other, so he's found the difference between those two numbers is 60, and he's added that same difference onto the population in 2011 to estimate what it will be in 2021. But that is not the same percentage. 60,000 as a percentage of the population in 2011, 60,000 over 420 is not the same percentage as 60,000 over 480. Okay, so we need to put that down somehow. So does the population of 540 match his claim? Okay, so first off, let's see if we can work out the percentage increase, or the percentage change, I should say. Percentage change from 2001 to 2011. What's that equal to? Okay, well, if you use the triangle that I often use in these problems, final, original, multiplier, percentage change, we want the percentage, which is kind of like the multiplier part. So we need to use final is equal to, sorry, multiplier is equal to final over original. So let's write that down as a formula. Multiplier is equal to final over original. Okay, so the final amount was 480. That's the amount in 2011. 411, 480,000, and in 2001 the original was 420,000. So tapping that into a calculator, 480,000 divide by 420,000. That's 8/7. That's not very helpful. That's 1.1428. So I'm going to write that. I'm just going to round it off to 1.143. Okay, so that is as a multiplier. So as a percentage, that is 114.3%. So that means the percentage increase is 14.3%. Okay, now let's work out the percentage change from the next amount if it was going up in 60,000 again. So kind of run out of space here. So the percentage change from 2011 to 2021, again our multiplier is going to be equal to our final over our original, which is equal to, well, what did he say it was? 540,000 divided by what it was in 2011, which was 480,000. Okay, and then dividing one of those by the other in my calculator. So I'm just going to type in 540 divided by 480 because that's going to give me the same number. I'm getting 1.125 now. So that's 1.125 as a multiplier, which is 112.5%. Okay, so that is an increase. I should have written increase over there. 14.3 increase there, and here it is a 12.5% increase. So they are different percentage increases. So what's the answer? Does the population of 540 match his claim? No. And we've got 14.3% and 12.5%. So our two percentages. Okay. There seems to be enough space there to do all the method, or maybe I'm just not using it well. Okay, let's move on. On 3 days, Ali throws darts at a target. Here are his results. So we can see he was throwing them on Monday, Tuesday, Wednesday. He threw 20 on Monday, 30 on Tuesday, and 40 on Wednesday. And there is numbers of hits and misses. So we need to work out two different estimates for the probability of Ali hitting the target. Two different estimates. Now, I think this is a bit of a bonkers questions, really. I think generally with relative frequency, you'd probably want to take the combined results and use that one with the most number of results. I think any other calculation you do is going to be not as good, but anyway, let's work it out. So let's try using Monday's results. Then our probability of a hit is going to be successful outcomes, which is 15 out of total outcomes, which is 20. So 15 out of 20. Okay. Or we could use Tuesday's results, or we could use Wednesday's results, or we could use the total, or we could use the total of two results. Seems a bit weird, this question. I'm just going to use using totals. And the probability of a hit is going to be successful outcomes, which is 54 hits out of total outcomes, which is 90 throws altogether. So my two are going to be 15 over 20 and 54 over 90. Although I can't say I approve much of this question. Right, let's move on. 7b. Which of your two answers is the better estimate for the probability of Ali hitting the target? Give a reason for your answer. Okay, well, I think using the total results, as I say earlier, would be the best because it's got the most amount of results. And you will find over time relative frequency homes in more and more onto probability, or in other words, experimental probability gets more accurate with when you increase the number of trials. So I'm going to say that 54 over 90 is the better estimate, and the reason will be, I'm going to say that experimental probability, which is what we're doing here, isn't it? Experimental probability improves when increasing the number of trials. Okay. Theo starts with savings of £18 and James starts with no savings. Each week from now, Theo will save £4.50 and James will save £4. Okay. In how many weeks will Theo and James have savings in the ratio of 15 to 8? Ooh, that's not very nice. Theo starts with savings of £18. Okay. Now, I suppose you could think of this as two linear equations, couldn't you? So Theo starts with savings of £18, and then so he starts with 18 and he saves £4.50. So if we did it like a graph, a y and x graph, then you know, x could be the number of weeks and y can be the total savings. So Theo would start on 18 and then every week he would save £4.50, so to increase by £4.50 and so on, and another £4.50, and it would give you a straight line graph, wouldn't it, like that, with the equation y is equal to 4.5x, because he's saving £4.50 every week, plus 18, which is your y-intercept, isn't it? So that's y equals 4.5x. Oops, I should have written it where you could see it. Y equals 4.5x plus 18. Then, so that's Theo's. Now, James starts with no savings, and he saves £4 each go. So he's going to start on 0 then, isn't he? And then he's going up by 4 each time. So kind of 1 along 4 up. So slightly less steep than the graph we've just drawn, and isn't it? It's going to have a slightly less steep gradient. So these graphs are going to be diverging over time, aren't they? Theo is going to start ahead and he's going to get more ahead over time. And the equation of that line then is going to be y is equal to 4x plus nothing. Okay, so then my two graphs then, and then so in how many weeks will in how many weeks will Theo and James have savings in the ratio of 15 to 8? So we've got to find a time where if we took a slice down here and we compared that point and that point, then one would be 15/8 of the other, which is not so nice. So like I say, clearly Theo is earning more and will continue to earn more, and the gap between them is going to get wider and wider. So it's going to be him who has the 15 and James who has the 8, isn't it, at that point? Okay, or you know, the equivalent ratio. So in other words, this value up here is going to be 15/8 of that one, isn't it? Okay, so if I take that equation then, 4.5x plus 18, I suppose what I'm saying is I want to find the value of x when that is equal to 15/8 of 4x. Okay, so what I'm saying is that's my yellow equation, isn't it? 4.5x, and this is my green one down here. So my yellow equation is 15/8 of my green equation. So then I've got an equation in x that I should be able to now go on and solve. Shall we try and do that then? So 4.5x plus 18 equals 15 lots of 4x over 8. Okay, let's just multiply out the bracket on the right. So 15 fours is 60x over 8 equals 4.5x plus 18. I'm tempted to cross multiply that 8 to get rid of it. So let's take that 8 and kind of move it over here. So that's going to give me 8 lots of 4.5x plus 18, and that's equal to 60x. Right, so multiplying out the brackets, 8 times 4.5 is 8 times 4.5. Could do it in my head, but I've got a calculator. So that's 36x plus 8 times 18. What's that? 8 times 18. That's 144. So I've got 36x plus 144 equals 60x. So let's subtract 36x from both sides. So that will leave me with 144 on this side and 60. Subtract 36, 24x over here. And then divide both sides by 24. I'm going to get 144 over 24. And that's going to be equal to my x. What's that on the calculator? 144 divided by 24. That equals 6. So x equals 6. So we're saying after 6, is it weeks? Yeah, 6 weeks. Then Theo is going to have 15/8 of James's wages. That was truly horrid. Okay, but we got there. Good job. Advertisement break. Hopefully you are able to use this past paper to identify any topics that you still need to focus on for your exams. It's best if you do some focused revision around these topics between past papers, and this series of videos will help you do just that. They are based on the AQA topic tests, including key topics like trigonometry, surds, indices, and a whole lot more. Click on the card above to go to the playlist. I'm adding to this collection all of the time, so if the topic is you're looking for is not yet covered, it soon will be. So subscribe below to make sure you don't miss out on any of these uploads. Right, back to the maths. Now we're told that the volume of a sphere is 4/3 pi r cubed, where r is the radius, and we've been given this diagram, which is a hemisphere, isn't it? A container is a hemisphere of radius 30 centimeters. So I'm just going to draw that on then. So here's the center of my sphere, and then the distance from the center to the edge in any given direction is going to be 30 centimeters. Okay, right, so sand fills the container at the rate of 4,000 cubic centimeters per minute. So I'm putting sand in at 4,000 centimeters cubed per minute. Okay, so I suppose it's slowly filling up then, isn't it? So you're going to get sand kind of appearing in the bottom here, slowly filling up. Right, so does it take less than a quarter of an hour to fill the container? You must show your working. Okay, so I suppose what we need to do then is to find the total capacity of that hemisphere. How much sand will it hold altogether? And then we're going to have to compare that with the rate it's filling up at 4,000 cubic centimeters per minute, so we can work out then how long it would take to fill, and we can see then if that is more or less than 15 minutes. Okay, so let's do that. Let's work out the volume of the hemisphere then. So the volume of the hemisphere is going to be half of the volume of a sphere, which is, we were told, was 4/3 pi r cubed. Okay, what's a half times 4/3? that is just 4/6, isn't it? 1 times 4, 2 times 3 is 4/6. 4/6 of pi times r. What were we told? R was 30, wasn't it? So that's going to be 30 cubed. Okay. So I suppose I need to work it out with the pi, don't I? So I'm going to have to type that into my calculator. I'm going to type 4/6 times 30 cubed times pi. Well, thank you, calculator. That's 18,000 pi, which is 56,548. Just going to write it down with pi in it in case I need to do some further calculation. And then I'll write it down as a decimal rounded off. So that's 56,548. Just going to round it off to 56,550, I think. 56,550. 4 significant figures at the moment, and I can drop down to 3 later perhaps. Okay, so that is the number of cubic centimeters that are inside that hemisphere. Okay, now we're told that it fills at the rate of 4,000 cubic centimeters per minute. So if I divide that number by 4,000, it should tell me the number of minutes it takes to fill. So time taken is going to be volume then divided by 4,000. Now I've written down the rounded off amount, but I'm just going to use the one that's still in my calculator. I'm going to divide that by 4,000 to retain accuracy. And I'm told now that is 14.137, which I'm going to round off to 3 significant figures, which is 14.1. So that is in what? Minutes? Okay, so if we answered the question, what was the question? Does it take less than a quarter of an hour to fill the container? That was the question. So did it? Well, it took 14.1 minutes. Is 14.1 less than a quarter of an hour? Yes, it is. So the answer is yes. The length of each side of a regular pentagon is 8.4 centimeters to 1 decimal place. Complete the error interval for the length of one side. Okay, so I always draw a kind of a scale when I'm doing these sorts of error interval questions, and I mark on the number they give me, and I imagine the scale either side of it. So if this was going up in 1 decimal places, then the next decimal place up from 8.4 is going to be at 8.5, and the one below it is going to be 8.3. So then the numbers that round to 8.4 are the ones that are going to be halfway between those two, aren't they? So halfway between 8.3 and 8.4 are going to round up to 8.4, and halfway between 8.4 and 8.5 are going to round down. Now, I know you're going to tell me that 8.45 rounds up, but it still becomes the boundary where you make the decision about where you want to round up one way or the other. So halfway between 8.4 and 8.5 is 8.45, and the other boundary is going to be halfway between 8.3 and 8.4, which is 8.35. Okay, so they form my two intervals, 8.35 and 8.45. You can see that this one is less than or equal to, and this one's strictly less than, which is why I can use that right hand limit. Okay, 9B, complete the error interval for the perimeter. Okay, so this is a regular pentagon. What does a pentagon look like? It is a 5-sided polygon. 1, 2, 3, 4, 5. Okay, so each one of those is going to be between, any one of those sides is going to be between 8.35 and 8.45. Okay, and what we're going to do is multiply those by 5. So what I need to do then is take the lower limit 8.35 and times that by 5. 8.35 times 5, that gives me 41.75. So that's going to be the lower limit, and then taking the upper limit, 8.45, and timesing that by 5, it's going to give me the upper limit, 42.25. Okay. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.